Let's see what's up. The weed though, nigga, that's weird. Who plays the
PJ.
weed, my nigga? You're a weirdo.
Pipe it up, BJ.
Fuck it. Okay.
Like a slow.
Oh, hello there. As you saw in the intro, we're gonna talk about hydrocarbons. But what are hydrocarbons without the IUPAC? Well, the IUPAC is the International Union of Pure and Applied Physics, which helps to create international and universal terms for making experiments viable. That means that if you make an experiment, the results you get can be get with another person making the same experiment. Some common hydrocarbons are alkanes, alkenes, and alkynes. And some examples are propane, butane, and methane.
Hydrocarbons are organic chemical compounds composed exclusively of hydrogen and carbon atoms. Hydrocarbons can be solid, liquid, or gases, and are what petroleum and natural gas are primarily made of. The way the hydrogen and carbon atoms are arranged and the types of chemical bonds that connect them determine what product they create. And then here you can see the main classification of the hydrocarbons that are the alkanes, alkenes, and alkynes. Those three are all organic hydrocarbon. And as you can see in the image, the first one is the alkanes, that the type of bonding contains all single carbon to hydrogen bonds. And the second one is the alkenes, that the type of bonding contain at least one carbon to carbon double bond. And the third one is the alkynes, that contain at least one carbon to carbon triple bond.
Inorganic compounds is actually easy. At first it's difficult because you don't know the rules of the basic of how to name them. Then when you learn the rules, it's easy because almost all the rules apply to all the organic compounds. This is why I think that naming organic compounds is actually easy for us. Alkenes are the simplest organic compound that we find, and the rules of naming alkanes are first identifying our parent chain, which means we need to identify the longest chains. This doesn't need to be a right chain, a totally straight chain. It can be bended or straight. Then we need to number the carbons, the ones that are closer to the substitute, and this is to get this is to get lower numbers and be easier to us. 3. Identify the alkyl groups. We need to find the alkyl groups. The alkyl groups are the compounds that are outside the parent chain. Then we need to name the alkyl groups. Naming them is we need to first identify how many carbons it has. Then we need to order them alphabetically. At the end, we need to identify the parent chain. By this I mean naming it by giving it a name with how many carbons it contains and at the prefix "ane". So this represents all the hydrocarbons. Here are the prefixes that are 1 methane, 2 eth, 3 prop, 4 but, 5 pent, 6 x, 7 pen, I think, 8 oct, 9 non, and 10 dec. So, and here we have the different types of hydrocarbons. That first we have 1 methyl ethane. That means that the first carbon we're doing is here because it's closest to the substance. Then we name first the substitute first, and then we name the parent chain. And this is a cyclic propane. A cyclic alkane is something that it's a closed figure. It has it is a closed figure, and it cannot be only 2 carbons. It needs to be 3 or more.
Okay, well, Now that we saw the rules for naming alkanes, we are going to name one alkane. Well, the first step is to identify the longest chain, that is also known as parent chain. That is this one. Then the second step is to number all the carbons that are located in the parent chain. We are going to start the numbers in the side that has the closest branch. In this case, if we start in this side, the closest branch is in carbon number 2. I mean 1 and 2. Here's the branch. And if we start in the other side, the first branch is located in carbon number 3. That is farther. I mean 1, 2, and 3. That's why we are going to start in this side. This will be carbon number 1, carbon number 2, carbon number 3, carbon number 4, carbon number 5, and carbon number 6. Well, then the other step is to identify the alkyls that are not part of the parent chain. That will be this one, and this one. Then we have to name them. Their names are methyl, and ethyl. Then after we've got all the information, we are going to name them. Well, the first part that has to be on the name are the alkyls. We are going to arrange them according to the alphabetical order. That's why this is going to be first. This alkyl is located in carbon number 4. Thus we are going to write 4 ethyl, comma. Then the other alkyls that are part of the compound are these ones that are the same. Because they are the same, we are going to put a prefix to indicate that there are two of the same name. And because they are both in carbon number 2, we are going to write the number 2 twice. Two, comma 2, dimethyl because R2, and then the last part of the name is going to be according to the number of carbons that are in the parent chain.
What I think about alkanes, alkenes, and alkynes, and even aromatics is that they can be very tricky when we talk about its molecular formula. But when we see its condensed formula or structural formula, we can distinguish them very easily by its single bond, double bond, triple bond, and in aromatic they have a cycle, and it is fun to do it while it doesn't matter if it's condensed or structural. You never know when are you gonna use them.